Well, good morning. This will be part of the Environmental Matters webinar series with the City of Superior Environmental Services, and it will be about the wastewater treatment plant, the process here at the facility. I'm Wendy, and I will do the first part, and Jillian will do the second part. Here's an overview of the plant. It's actually not up to date of a photo, but you can see there are multiple buildings here and tanks in different areas, so we'll be taking you through this process. We're located on Superior Bay, Superior, Wisconsin. Here's another view that's getting to be more accurate. We've added a building here, the UV building. A new sign was just added a few weeks ago to help you get here. And Jillian will talk about more things, why you'd come to here, so you can see that nice and visible. And we're located in this building on the second floor, and there's the door. The main control office building is a newer addition just from the 90s, but the plant dates back to the 50s, and additions were also made in the 70s. What comes here? So we are part of the sanitary sewer system for the City of Superior. So sanitary sewer pipes are underground, about 70 miles of them, with lift stations along the way to assist the flow. And what comes here is wastewater. Wastewater is coming from your sinks, showers, anything down drains, toilets, washing machines, sorted appliances, and then from businesses as well. They're from homes, schools, businesses, and public authorities, which includes the government. And there's 9,800, about that many hookups. We also have trucks coming in every day from septic holding areas and porta potty businesses. And then from the landfill, the leachate that goes through on the bottom, that comes through here for a final round of treatment. We also, part of the city has a combined sewer system, so some stormwater does come through here, but overall stormwater and the storm drains in the street are separate and are not treated here. At the wastewater treatment plant, we have several goals. One is to remove phosphorus. There's a screening process. We're going to remove grit material, remove suspended and dissolved solids. We're going to use sludge, activated sludge. There'll be a portion of the step where we want to take out water, dewater material, and we do want to disinfect. The water that's released has to be of standards as in our discharge permit. This is a quick little overview flow chart of the steps along the way. You can follow the blue arrows for the general process, but there's some arrows in the other direction, and that's where activated sludge will come and be part of the process. And there'll also be liquid removed in some and be sent back into the steps. There's also gas that will be released, and then 3 points of the process have materials going to the landfill. The process is a combination of both physical effort, chemical effort, and biological treatment. Here's another way of looking at it. It can be described as preliminary treatment, where we screen it, add ferric chloride, it goes through grit chamber and a pump, and the primary treatment, which is the physical treatment, slowing the flow down, and it'll involve clarifiers and polymer. And then the secondary treatment, aeration tank and a final clarifier, and then a process to handle the solids and disinfect the water before it's released. And for how much comes in here, an average flow on a daily basis is almost 4 million gallons per day, but certain times of the year it's much higher. During snow melt in the spring, that's our higher flow time, and then also there's greater flow here during a storm or directly following a storm. and our plant can handle up to 7.6 million gallons per day. How clean is the water? It's called influent at the beginning, and it's mostly water, but there's a mix of suspended and dissolved matter that needs to be removed. During different steps along the process, different amounts are removed. For instance, after primary clarifier, that step, 45 to 65% are removed, but there's still more to go to make it releasable as effluent to discharge into Superior. And here we'll go through a picture of each of the steps for the influent to go through. The first place is the screen building, and that's right on the outside. That's where the sewage trucks hook up. But underground, the pipes, here's another information on the sewage trucks. For a sample of just in a week's time, over 70 trucks come and dump quite a bit. But that quantity, those gallons, don't come anywhere near the amount of gallons flowing in, again, through the underground pipes. So underground, the influent enters the screen building, and the main big equipment in this building are these rotomats, and they turn and turn and help to remove the physical bigger items up to or down to a 1/4 inch size. And it'll go through and take out some rags and debris material and have that, and that will head to the landfill. Also in this building is a big tank in the background, and that's where contains fluoric chloride, and that is added as part of the treatment to remove phosphorus. The next step, water would go to the grit chamber, and this is a spot that removes inorganic solids, both grit, sand, cinders, eggshells is a mix. Air is added to help keep the flow going and settle out some of these solids. Sometimes we can also see some grease balls on the edges. In that step there is a monitoring step, and several places along the way are these situations where they are taking samples. Here's a sample of what grit looks like, and it has no real odor to it. It's kind of like wet kitty litter, wet clean kitty litter smell. The next stop is the pump building, and again there were lift stations along the way to bring the influent over to us, but this pump building is going to take the material and bring it up to the highest point of the property here. Inside the building there's 4 pumps, and we have extras just to handle if there'd ever be a problem with a pump. We need to have those good solid pump ready to go always. So depending on a normal flow of about 4, then only 1 pump is spinning, but on higher flow then 2 pumps are going. There's the view down below from the pumps. So it's going to pump it up to this higher area. This is the blower chemical building, and the tanks are on the back side of this building. Inside the building are some equipment that will be part of the aeration tanks that will follow this step. And then there's chemical added, a polymer is added to help clump some material. Different monitoring equipment set up. And then here are the actual tanks. These are the primary clarifiers, and they're 700,000 gallons capacity, and the liquid here spends about 4 hours time and just settles down. The process of giving this settling time enables certain things to settle out, and again the polymer that was added also is part of helping things clump together so that they will settle. Some are settling, some are sinking, some are floating, some are settling, and these screens are slowly moving across, and will go to the end and then come back around the bottom. And then at the end of the row has more of the floating material, and those will be part of the sludge. There's weirs at the end that are also just having the flow of water, trying to trap any materials along the way. and then Jillian will continue through and take you through the next few steps.
So Wendy left off at the end of the primary clarifier. So from the primary clarifier, we move to the aeration tanks. So this is just what they look like from afar, but this is what they look like close up. The aeration tanks are 17 feet deep and hold 700,000 gallons of water. The water spends about 4 hours there. So what happens in the aeration tank is that the bugs, the microorganisms and bacteria in the water are given favorable conditions. So oxygen is added because they like a lot of oxygen. So we add oxygen to it so that there are good conditions for them to eat the organic matter that's in the water. So we're basically just trying to make a nice environment to keep them happy and eating. So they eat up the organic matter in here. And then, so this is just another picture with information about some of the organisms that are in the water. So then all of the water from there goes into the final clarifiers. But the return activated sludge, which is sludge that's been in the final clarifiers and then gone back to the primary clarifiers and then comes back here to the aeration tanks, keeps more bugs in the water, so that the sludge goes through again and brings more bugs in. So once the water leaves here, it goes over to these tanks, which look remarkably similar to the primary clarifiers, and that's because they're clarifiers as well. These are the final clarifiers. They're 16-foot tanks, and it can hold 650,000 gallons of water. Again, the water's there for about 4 hours. So what happens in here is pretty much the same as the primary clarifier. The water's slowed down, and stuff that's in it, any of the sludgy solids, can settle down to the bottom. The bugs are removed here, so the things that are removed here are sent back to the primary clarifier. The bugs will go back to the aeration tank, like I said before, and eat some more and keep breaking things down. Like I said, the other solids go back to the primary clarifier, and then those eventually will go to the digester, which we'll talk about in a little bit. But at this point, at the end of this settling process, the water is about 93 to 95% clean, but it still has some things in it like viruses and bacteria, so it still needs to be disinfected. These are just a few more pictures of the cloudy water. So these are the old chlorine tanks where chlorine was added to disinfect the water, but that is not done anymore. This building, the ultraviolet building, was built in fall 2012 and was used as of December 2012. So the way that this works is the water is disinfected with ultraviolet light. So we have these two different bays of lights which look like this, and basically the water passes through these bays of lights, and all of the water goes within a certain distance of the light, and what happens is that the ultraviolet radiation inactivates the things that are in the water, so the bacteria and viruses can't replicate and reproduce. Yeah, so those are the ultraviolet lights, and once it goes through there, it's clean, and it comes out the end here and then goes out into the bay, and that's the cleaned water. So that's where the water leaves the plant. It goes through that whole process and then goes out into the bay. Oops. But then the solids that went back to the primary clarifier, those go to the digesters. So this big round building shown here is a digester, and it stays in there, the solids stay in there for 10 to 14 days. So in these we have bugs that don't like oxygen. So the sludge in here gets heated up pretty hot, and it's an anaerobic environment, so there's no oxygen in there, and it just sits there and kind of bakes for 10 to 14 days. And once it's done, it's still got a lot of water in it, so it ends up going to the belt filter press, where some of that water is removed. But one important thing to note about the digesters is that this cooking of it basically produces methane, and the methane is being burnt off here, but the methane can also be used to heat the process as well as the offices here at the wastewater treatment plant. So this is the belt filter press where we're going to remove some of the water that's still in the sludge after it's been baking in the digester. So this is just kind of what the building looks like. But there you can see it's kind of like a conveyor belt, and what happens is the sludge runs through it and it squeezes the water out of the sludge. So when you see it running, you can see water pouring off of it, and that water ends up going back to the primary clarifier and going through the process and getting treated. But the sludge, at this point, we're done with it, so it gets the water squeezed out of it. It's still about 75% water, but it goes onto a truck and goes to the landfill. There you can see the conveyor belts a little bit better, and there's the truck that takes it over to the landfill. So that's the wastewater treatment process. The water leaves either in the sludge or treated out into the bay, and the solids leave either from the screen building to the landfill, the grit chamber to the landfill, or the belt filter press to the landfill. So before we end the webinar, we're going to stop and talk about a few different things that you shouldn't flush. Actually quite a few things that you shouldn't flush. Basically, the idea is that you shouldn't flush anything that's not, human waste or toilet paper. Even things that you would think would be okay to flush, like tissues, aren't meant to break down. They're not created to break down the way that toilet paper is, so you shouldn't flush them because they can clog your pipes. So a lot of these things can clog your pipes, like fats, oils, and grease. We did a webinar about that over the summer. Things like that, if you put, greasy food, even if it's liquid, when you dump it down a drain, it can cool down once it's in the pipe and kind of block things off and cause problems here or along the way. Other things, will just clog up your pipes. Household hazardous wastes can actually corrode the pipes depending on what they are. So all of these things you really don't want to flush down the toilet or put down the sink or anything like that, because it can cause you problems and it can cause infrastructure problems. So one more thing that we'll talk about before we're done is other things that are here at the wastewater treatment plant. So in addition to wastewater, we also cover stormwater here at the wastewater treatment plant. We have a few different things that we do for stormwater. The utility bills, that kind of stuff is taken care of here. We have the stormwater hotline, so if you notice anything that could be a potential source of pollution for stormwater, feel free to give us a call at the hotline. We do illicit discharge sampling, and we take the reports from the hotline and look into them. The stormwater flood control program, Kurt Sanderberg is in charge of that program for people who have had their basements flooded and are interested in talking to him about it. We have native plant rain gardens, so demonstration gardens for people to come see, what kinds of things you would put in a rain garden, how to build them, things like that. We have several of those here at the wastewater treatment plant that Wendy does tours of, and you can also volunteer to help in the gardens if you're looking for something to do during the summer. We also have education here at the wastewater treatment plant, and that's a lot of what Wendy and I do. So we have booths at a lot of local events, things at the Mariner Mall, at the library, pretty much any local event that is relevant we'll attend. Speaker nights, so Wendy has organized the Native Plant Night, a pollution prevention night, and she has one coming up on recycling this week on Thursday? Yeah, Thursday. So that will be at the library if you're interested in attending. We have displays around town, so there is a display cabinet at the Mariner Mall that you could go check out. Right now we have information about low impact development. There's also a display at the Blaine Business Center, so right across from the Center for Muscle and Joint Therapy, and by the Jimmy John's entrance there is a display about mercury. We do storm drain stenciling, so we are always looking for people to volunteer and help us paint pollution prevention messages near storm drains. We do wastewater treatment plant tours, so if anyone's ever interested in attending a wastewater treatment plant tour and seeing this process firsthand, feel free to give us a call. We have a blog that we pretty consistently post things about stormwater, pollution prevention, wastewater, anything related to that. We have a Twitter and a Facebook as well with information about our upcoming events. We do webinars, obviously this is one of them, but we have two series, the Environmental Matters webinar series and the Businesses Preventing Pollution. There's a stormwater newsletter that goes out with every stormwater bill. The Adopt a Storm Drain program, you can volunteer to keep a storm drain clean, and you can contact Wendy if you're interested in that. And disposal guide, so we provide information about where you can dispose of things in Superior, or if Superior doesn't have a place to dispose of it, we give you information about Duluth as well. And that ties into something else that we do, which is recycling and disposal drop-off. So in our disposal guide you might notice that Superior ESD is one of the locations that you can dispose of things. So we have here, we accept rechargeable batteries and cell phones and mercury-containing items. So some examples of mercury-containing items would be fluorescent bulbs, thermostats, thermometers, auto switches, things like that. And if you do bring a mercury-containing thermostat, you can get a non-mercury thermostat for free from us. So feel free to bring that in. Our hours are Monday through Friday, 8 a.m. to 4:30 p.m. So that's just a quick overview of some of the things that are done here at the wastewater treatment plant. I'm sure there are tons of other things that aren't covered, but if you have questions about any of these things, please let us know. And thank you for attending. So again, this was part of our Environmental Matters webinar series. You can check out what archive topics we have or register for a webinar at www.ci.superior.wi.us/webinar. And our next webinar is Superior Stormwater Education, and that is on November 26th at noon. And that will be the last chance to enter the drawing for a compost bin. So if you attend that, you will be entered into the drawing. Thank you so much for attending. We'll end the webinar now.